Hi, I'm happy to be with Ernesto Reina today, our new author of Essential Electrical Skills for HVACR. Ernie, it's great to meet you, and I'm happy to introduce you to all the folks at the HVAC Excellence Conference. Thank you for being here today.
Thank you. Thank you for having me here.
I thought if we could start, if you could just tell everybody a little bit about yourself, your background, and how you're associated with the HVAC industry and HVAC education.
Okay, fine. Well, my HVAC career started with Lincoln Tech. Amazing how that works out. And here we are at Lincoln Tech again, but many, many years later. So it all started with Lincoln Tech. Once I graduated, I worked in the field immediately, heating, air conditioning, did refrigeration work on my own. I had my own side business as well for a while. And after a few companies and more knowledge gained, I wound up with General Motors, which is now more of an industrial arena, but wound up in the automotive section of it. However, doing HVAC, because that was my favorite subject, I guess, and where I was really great at. And so then that led to more schooling, more education with electronics, electrical, which was always a favorite. Even before Lincoln Tech, I always had something about electronics, something that I really liked. I loved electronics, so I continued to study that and apply it to the HVAC industry. So after many years with GM and having worked in many facets of the automotive with all electronics now, engine controls, body controllers, all automation, again, controls, big emphasis on controls. I wound up teaching at Lincoln Tech, where I am now to this day. So now, in addition to the courses that the school offers, we also do customized training. That's where I am currently. Customized training, where we do programs for industrial boilers, for example, at hospitals. Whatever's out, whatever challenges there are out there and somebody needs our help, we're there. And so that led to writing this book, actually, after a while.
Okay, well, Ernie, can you tell us a little bit about your motivation in writing Essential Electrical Skills for HVAC? It's a big task to undertake, so let us know the whys.
It was enjoyable, too, at the same time. Because it's something that I guess I wanted to do for a very long time. Because I began teaching back in the GM days, even before that. I seemed to have the knack for electrical. I mean, and so I was that guy that was teaching electrical to the technicians, both at the GM site and other companies that I worked with. Okay, so now what I find today is that technicians need to know more about meters, for example. Troubleshooting is key, and they're lacking that. There seems to be a lack, and I hear that from many of our customers that hire our students, different companies out there, that yes, they need more on the troubleshooting skills. They need to learn how to use a meter better. And that's one of the focuses of my book here, is to really talk about the fundamentals, understand the fundamentals so that they can appreciate what that meter does, and then be able to troubleshoot. And that's what we do in this book.
So your book, the subtitle is Theory in Labs. Can you give us kind of let us know what the balance is in the book, where you discuss both theory and provide labs? How does that work in the organization of your book?
Okay, for each chapter, there are 3 labs that are directly tied to the subject matter that we're teaching. So that's something else that we need out there. We need to have the labs directly right in the book, as opposed to having separately. They're right there. So at the end of every chapter, you're going to go and practice your skills.
Okay.
You're going to do the labs. In addition to that, there's questionnaires for the general chapter itself, but also for the lab work. And so this way, it forces that student to, okay, well, I do understand this, because they're actually, the work they're doing, they're going to now back up through the questions.
Now on the cover of the book, it talks about this content being able to work very well with GW's modern refrigeration and air conditioning. Can you talk a little bit about how your content would fit into different HVAC courses and any suggestions you have for instructors to use the material either with or without modern refrigeration and air conditioning?
Absolutely. The book is such that it can be used either way. It can be used along with the MRAC book or a standalone. Okay. No one book can ever cover everything needed. However, what I do here is give you the fundamentals very well explained, very concise, to the point, quick, so that each student can have the ability to now go ahead and further explore on their own, to further analyze different systems that are out. So by giving you those fundamentals, you're ready to go. You're ready to tackle any other type of program.
And then as far as any instructor challenges in teaching electrical skills to students, have you found any challenges yourself as an instructor in trying to prepare these students to be technicians with these key electrical skills, or any advice you can give to other instructors for helping to, prepare these students with these skills?
Well, I see that the students need to touch and feel. They need to grab that meter. They need to actually go out there and perform what they have learned, to actually get a good vision of it. Okay, and that's what the book attempts to do. Give this student that here it is. Now you do it. You try it. And together with the labs and the questions, I believe that is accomplished.
Now we're hearing often that students don't like to read. Did you design your book with that in mind?
Yes, yes, because I want to keep as many. Well, I don't like to say unnecessary because everything is needed, but we want to make it as easy as possible, as not to bore them with too much information. Whatever they need is there, right? The absolute necessities are there, presented, and then they can go on, for example, and read additionally.
So Ernie, I know you worked with some colleagues and other instructors across the country to provide reviewer feedback as you were developing your book. Can you tell us a little bit about some comments you may have received from the reviewers?
Right. One in particular is the order that the book is written in. Okay, where they like the logical sequence, and that's what I was aiming to do. Logic, because it's got to fall in place. So how we start the book, for example, electrical safety. We need to start with safety because of its importance. Yet, however, the students don't know enough about electricity, right, to understand a full-blown electrical safety chapter. So what we do is just introduce what's necessary, enough to get them started, and then as we progress in the book, we'll go back and talk about those items again. Okay, now they have an understanding. We then go into electrical fundamentals. Absolutely have to have a foundation to go with. The simple circuit is followed because we want to introduce them now. Okay, here is a circuit. Now that also starts allowing the student to see what a diagram is, a wiring diagram. So we start piecing them in little by little, getting them in there, and now go into Ohm's law, which is the heart of electric. Got to have Ohm's law. You have to understand that fully in order to understand the rest. So now, after Ohm's law is dealt with, we go into types of circuits. So now we expand. Okay, well, now you had a simple circuit. You understand the fundamental laws. Now let's build upon that. And let's take series circuits, parallel, complex. Let's talk about residential and commercial conductors, the wires. Let's talk about the parts that make up that circuit. And after that, we go into alternating and direct current. This is the power sources that are out there. So we break that down so that they can understand fully what they need. Okay. Electromagnetic devices is next, chapter 7. Now we look at all the components that that make up the majority of the components in the HVAC industry. These are electrical, mechanical devices. Each device is broken down as to how it operates, how to test the device, what can go wrong with the device. So everything is right there in one place. And that's something that the folks that looked at the book, feedback I received, yes, they like that because it's all there, all in one place for them to look at. Now we're going to capacitors, other type of devices, so they can understand exactly how a capacitor works, how to test the capacitor, why do we use them, and they're important. So now they should be able to master everything about capacitors all in one chapter, as opposed to having the capacitor shown in different paragraphs, right? Or in some cases in a different book altogether. So it's all there for them. Power distribution. What about the power? Where does it come from? And how is it distributed in the house and in commercial establishments? All the necessities are there. So now the student now understands all this, and now we're ready to go into electric meters. How do meters really work? What goes on inside the meter? Because that's something that in other cases is missing. I believe that information needs to be there so that they can appreciate how the meter is going to be used in troubleshooting. And so after the meters in chapter 10, we move into chapter 11, where we now talk about practical circuits. In practical circuits, now we break down, okay, what circuits do we have in a typical air conditioning system, typical heating system, refrigeration type system? What are they? And so now this breaks it down to that. All right, so now we know how the simple circuit started, right, way back, and now we have brought it on to an exact application, for example, in air conditioning. Beyond that, now we take a closer look at the component again, which is electronic components. Electronic components today are obviously necessary because everything today is computerized. Everything today is digital. And so the controls, right? We have digital controls everywhere, from residential all the way up to the high industrial units. At one time, only industrial equipment had the digital equipment. Now see, even on a residential scale. So it's very important. That's why I dedicate a lot of time to that, to show how to troubleshoot circuit boards, how they work. Let's talk about computer logic and how that is applied. And so that is all found in chapter 14. Chapter 13, which I excluded for a moment, is all dedicated to electric motors. So now having the idea of what is AC, what is DC, how does all that work, circuits. Now we can talk about motors and get a full understanding of motors, different types, from your standard motors that are, by the way, going out the door because soon they will be history. Today's motors, ECMs, variable frequency drives, that's what's going to govern everything. They will be used and someday 100% of the time. So we need that definitely in the book. And then we're going to three-phase motors, compressors. Chapter 14 is again printed circuit boards. How do we understand those controls? What goes on inside of that board and how to troubleshoot, which is something that I found lacking, okay, when we started talking in the beginning, as you know, some of the challenges that are out there. Well, we need to understand how to troubleshoot a circuit board. And finally, chapter 15 is a troubleshooting overview, where now we bring everything together and talk about some real live systems, heating and air conditioning, so that now the student can apply all this knowledge and take it on beyond that. If you want an industrial system, large commercial, they can do it.
So now, how could a student prove to their future employers that they have earned these skills and that they are ready to go as an entry-level technician? Are there any sort of benchmarks that they need to pass in order to be employed as an HVAC technician?
Well, many employers will be thrilled if the student can use a meter. And that right there in itself, many employers ask that question. Many employers will ask pointed questions. What is this? What is this part? How do you check this? How do you check that? And if the student can answer those questions, I think he's in.
They're on their way. Excellent.
They're on their
Excellent.
way.
You had mentioned to me
The evidence is here because they can actually show some of the lab material that they have done. I noticed that the book, the pages are perforated so they can pull out lab sections. Bring it on an interview if possible.
Good idea. That's great advice. Keep a little portfolio together of all the labs that they've completed. Yeah, that's a great idea.
It's something that a student should focus on. Hey, what have I learned over the time? And what can I do? And so here it is.
So Ernie, can you talk to our instructors here today about how the content in your book could be incorporated across different types of HVAC curriculum programs?
In programs where you're going to have a basic electric class, for example, you can just use the first parts of the book and then use the remainder for specific sections, such as air conditioning, heating, refrigeration work, dealing with computerized digital controls, for example. So that can be brought back to that. On a college level, where you have semesters that are 12 weeks long, the book can fit in there as the semester, entire semester, plus then brought back for any specifics. Again, dealing with digital controls, air conditioning related, heating, and so forth. So that it's very broad.
So Ernie, you talked about the labs that are included in every chapter in your book. Can you tell us a little bit more about how the labs are set up and how instructors would use the lab activities with their students?
Okay, one thing I did is make it so that it's easy for the instructor and the students to be able to actually perform the labs. And that is by giving them a list of materials to use and actually a workspace that we call it. It's a template that they can build and use that same template throughout most of the labs. So all that they're doing the same template and they're just adding the new components. So everything is laid out, and we also have part numbers for them to purchase, so they can look at all the labs in advance and have everything ready. So such that when they're ready to do the lab, the parts are all there.
Could students do this lab work in their homes, or do they need to be at school in a lab setting?
The majority they can. The only exception, one exception, would be where they need a piece of equipment such as the air conditioner furnace itself. But again, it can be adapted to any. So we don't have a specific model that they need for their central AC unit, for example.
Oh, excellent.
And I think that's a big advantage.
For sure. So where would they order parts from? I'm just curious.
Well, on the internet. There's a couple of places. Everything's on the internet today, right? But we have a couple of electronic places. DigiKey is one, for example, and there are other. There's a couple of dedicated, HVAC type establishments, and they're all listed. Everything is readily available.